Okay guys, so today's question is the user will give us 3 points and we have to tell whether the 3 points make a triangle or not. Okay, so this question is comparatively easier rather than the other questions I have already done. So the details are the user will give us a matrix or a vector which will provide us the input arguments, which will be the coordinates of the points that will form a triangle. We have to check whether they will form a triangle or not. So x1 and y1 are the coordinates. So he will first provide us the three x coordinates or abscissa, then he will provide us with the ordinates. And we have to tell whether the triangle is formed or not. Okay, so let's talk about all the possible cases. The number one case is that the triangle is formed. Okay, this is very easy as we all know. The second one is a straight line is formed. Maybe all the 3 points are in a straight line, or you can say the area of those 3 points are zero. So this is second case. The third case is what if two out of the 3 points coincide? Like this is 1 point and another this is 1 point and then this 1 point. It makes a straight line, right? Okay. And what if all those 3 points coincide? That will make a single point, right? So these are possible four cases in which in triangle this we will show triangle. In these two cases we will show straight line, and in this case we will show a point. Okay. So let's get into it. Okay. Okay. So let's write our function. Let's okay. So let's start writing our function. uh, I am not giving it any fixed output right now. Let's name our function as triangle, and we will simply take x1 x2 x3, then y1 y2 and y3. Okay, so we made overall four cases, right? So first of all let's write our best case. Or first of all let's define a matrix. Let's say A that will be equal to x1 x2 x3 y1 y2 y3 and then 1 1 1. It simply means A is the matrix that we use to determine the area of a triangle. So let's say if the determinant this determinant is an inbuilt function of matrix. I'm using it because I am saving time. You can do it in many other ways also. You can use Heron's formula to calculate area, or you can use there are many other ways, right? You can use half of x1 or x2 plus x1. So there are a lot of formulas. So just to save time I'm using determinant here. It is an inbuilt function of MATLAB. MATLAB is meant for matrix, right? So okay, if determinant of determinant of a matrix is not equal to 0, which means that the given set of numbers form a triangle. So we will simply say that yes, it is a triangle. And else, if this case is not satisfied, which means determinant of a is equal to 0, which means that it's not forming a triangle, then we go to three cases. Either it's a straight line or either it's a point. So let me write the else statement. In else we will write a nested if statement, that again if either the first column, you see it is column wise, this A matrix is something like, if this is the matrix, then x1 y1 1, x2 y2 1, x3 y3 1. So if the first column is equal to second column, which means x1 is equal to x2, y1 is equal to y2, or any other random pair just like this, which means that the 2 points are coinciding, right? So I'm just writing that statement, that if the first column is of matrix A is equals to the second column, and I'm using a single AND operator because I'm not dealing with scalars, I'm dealing with matrices. So let's just copy paste here the same thing, and then we will use same thing again. And this we can simply do this thing by loop also, but I am not getting into that much. Okay, so if I have just alternate three conditions, that whether that either the first column is equal to second column, the second is equal to third, or the first is equal to third. In all, and if these three cases are satisfied together, I don't need this third one by the way, because if one is equal to 2 and 2 is equal to 3, then it automatically means that. So if this is happening, then we can say that no, it is a single point, right? Because if this is happening, then we can say that it is a single point, and if this is not happening, then we can say it is a straight line. I'm sorry for the spelling of my straight. Okay, I hope so it's right now. So straight line, and we will simply end these statements. Okay, so why this throwing error? When both arguments are numeric scalars, consider replacing it. Well, here are not these. We are not dealing with those, so it's just a useless device here. So let's save this function as triangle, and then let's check it out whether it's work or not. Let's say 1 1 1 1 1 1 1, easiest case. Okay, so it's showing that it's a single point, and that's true. Let's say 1 1 2. It shall show that it is a triangle. No, it's a straight line. Ah, yes, it is a straight line because 2 points are coinciding and the third one is different. So it is like this. Okay. Now if I do it like this, then even then it's a straight line. If I plot a graph of this, then 1 comma 1, 1 comma 2, and 1 comma 3. So it's actually y axis equals to one line. So yes, it is a straight line. And if I do something like this, then it is a triangle. Okay, if I want, then I can show that area also. Simply say that, let's say this is the area which is equals to determinant of capital A. Okay, so we can simply write with area, and then we can say percentage G. This is an inbuilt function of fprintf, as we can say the area. Okay, so this was our, let's control process to save it, and then like if I, this wasn't, let's first of all let's okay, so this is working. So it is in, okay, so first of all we have to do some changes in it. This is working, one thing for sure. I have to multiply it by 1 by 2, and also I have to take absolute of it, and then I have to add a line break here. Okay, so now that's look fine. Control process to save. No, I don't wanna. First of all, let's enter. Okay, no, okay. So as you can see, this is our function now. Let's try something crazy here also. Not too much crazy, simply not going out of my bounds. So here, as you can see, the answer is 4.5. Okay, so our function is working right now. So thanks for watching. I hope you liked it.